Hello, my name is Cameron, and today we will be demonstrating the Cydarien fuzzing tool. We will be demonstrating the tool by fuzzing version 4.02 of the Xpdf file reader for Linux operating systems. At the time of this recording, this is the current, most up-to-date release of Xpdf. First, we will upload our package containing Xpdf, which is in a tar.gz archive format. The tool will upload the package and then prompt us for configuration information. You can see the name of our package here, xpdf.tar.gz. And by default, the tool assumes that you have a config file included in the package. But if you don't, you can deselect this and include configuration information here in this form. I'm going to select this option because I do have a configuration file included in my package already. Then, when you're ready, you can start fuzzing. After you upload the package and start the task, the fuzzing tool will process the task, and then when it's ready, it will add it to our active tasks. As you can see, the newly uploaded task has been processed and is now visible in active tasks, which means it's going to start being fuzzed. Before it can start fuzzing, the new task needs to go through some startup steps. So while that's going on, let's take a look more in depth at what's in our package. Here are the contents of the archive that we uploaded. You can see it contains a directory containing Xpdf, another directory called in, which contains sample input files for the application, and finally, a configuration file called config. Let's take a closer look at that file. As you can see here, the configuration file contains information that is important for our tool to be able to automate the fuzzing process. Things like the path to the target executable, the language of the executable, and any dependencies of the target application. Let's go check back and see how our task is doing. As you can see, our task has finished with its setup and has already began fuzzing our package. In fact, we've already found 4 crashes for this package. We can see a more advanced version of this table by clicking See More. This gives us more information about our fuzzing task at a glance. We can view stats for this fuzzing task by clicking the Show button, which you can see here. If we want more information about this fuzzing task, we can view a report by clicking on the xpdf.tar.gz name. This report screen contains important and useful information about our fuzzing task. First, you can see here we have a couple of pie charts which show us information about the crash's exploitability and its crash signals. If we scroll down, we can see crash statistics. It gives us the number of unique crashes, the number of duplicate crashes, and the number of total crashes. Additionally, we can click the View Plots button here, and it gives us plot information, which is useful for determining whether or not we've reached a point where we can stop fuzzing the application. We also have coverage statistics. We show how many files we've covered and our average coverage for each file. Down here, we have a crash table. This crash table contains a list of all of the crashes discovered for this fuzzing task. The fuzzing table shows for each crash the file name, which we can click to view here, the exploitability, the signal, a description, a hash value, a type, unique or duplicate, and we can view the stack trace for that bug. As you can see here, this is only one to 5 of 9 available crashes for this task so far. We can also download these crashes by clicking on the Download button. Down here we have a coverage table. This lists all of the files that we have for the package and shows our percentage of coverage for each of those files. We can also view a more advanced version of the coverage by clicking on one of these files. The file's source code will be loaded into this page, and it will show us line by line which lines have been covered and which lines have been missed. You can see here NA because this is a commented line and does not count towards coverage. We can filter out these NA lines here. So as you can see, we have a number of lines hit and a number of lines that we've missed. And we can see the number of times that we've hit each of these lines. So what we'll do now is leave the task to fuzz for a little while, and we'll check back in later to see how many crashes we can find. So, we've had the task fuzzing for a little while now, and as you can see, we found many more crashes. We can check these crashes in the report, but that would be a lot of crashes to check through, and we might only care about a few of the crashes. As you can see here, only 2 of the crashes are actually unique. So in the crash table, you can add a filter to only show the unique crashes, which are these 2 here. One which is probably not exploitable, and one which has unknown exploitability. We could then download both of these crashes and use them as inputs for the target executable to see what sort of crash it's causing. While we were fuzzing this package previously for a longer period of time, we actually discovered an exploitable crash that we can demonstrate now. We found an exploitable bug after fuzzing this package for a few hours. Today is the 22nd of August, and this is the latest version of Xpdf, and we'll show the exploitable bug that we found when you're using Xpdf to convert a PDF to text, which would allow an attacker to execute malicious code on your computer. In order to prove that it is exploitable, we are using the GDB plugin called Exploitable. We run the exploitable file in GDB. You can see the crash here, and to check the status of the crash, we just type exploitable. The description is a heap error, which indicates heap corruption. We can see that it is exploitable with the abort signal, and this is because of a bad pointer to a heap function. And that brings us to the end of our demonstration today. We have successfully found an exploitable crash in the latest version of Xpdf. Thank you very much for your time.